And we are live on YouTube. So welcome everyone to our 14th coffee. And today Max will dive into Kubernetes, K3S catch-up, I think. And everything around Hetzner Cloud, Hetzner Online. And in the beginning, I also want to mention that we got sponsored by Hetzner, or like what we're going to do today, we can do for free. And yeah, with that, I would just like to hand over to Max. Give us everything.
Okay, should we do a short introduction? Who is here, or
no? I think you can just go ahead.
All right. Yeah. Okay. Cool. Then welcome everyone. Yeah, I'm Max from Germany, and a while ago I was talking to Michael on Twitter, and we are talking about Hetzner and Kubernetes and that it's interesting stuff. And he invited me to this meeting, and so I attended a few times now. And today I wanted to start to look into Hetzner and into Kubernetes with all of you. And so it's not like a conference talk. It's not like every word is prepared. I prepared some demos and some rough agenda, what we are going to do, but the rest of it is improvised. So we can talk about it. We can do something else if we realize we want to test something. It's completely free what we are actually going to do. So for everyone who is looking at the live stream for the first time, in this meeting, we usually just do whatever we want. We test something, we play around with technology. So also if you're in the live stream and have questions, you can ask in the chat and we will try to react to it. So what I did since Christmas in my free time was to migrate some of my personal infrastructure towards a new Kubernetes cluster. And I set this up on Hetzner. Hetzner is a German cloud provider. And I used K3S for this. And I wanted to have it completely reproducible. So I decided to build a GitLab pipeline to start from scratch. And when the pipeline is finished, you have a fully running Kubernetes cluster in there. And that's taking quite a lot of time, and it's a lot of moving parts. So I don't think that we will go through everything today. So we will start today with part of it, and then maybe next week and the week afterwards, depending how fast we go, we can look into more of it. And depending on how fast we move and into how much details we want to look, yeah, it depends a little bit if we need 1 hour or 5 hours. So before we start from scratch, I want to look a little bit at, or give you an overview of what the final version currently looks like. What you can see right now is my personal GitLab instance. And this is a pipeline running, which does everything to create a new cluster. And there are a few different steps. At first, it uses Terraform to provision all virtual machines, all networking stuff that is required. If this is done, oh, this is a bad example. There's one step missing here. There comes a second step where it uses Ansible to configure those virtual machines. We will see this later, so don't be confused that it's not here, but here's a step missing. Then when this is done, I'm using Tanker, which is another tool we will learn about if we want to, which creates the first few things in the Kubernetes cluster, like namespaces and stuff. If you don't know about Kubernetes namespaces, don't worry. We will see this today or next week. And then in the end, I'm using Helm file, which is a wrapper tool around Helm. And Helm, you can imagine that as like a package manager for Kubernetes. And we are going to use this to install more software in our cluster. And yeah, each of those steps can be, we can look at it at like just an overview, or we can look into it at a very detailed level. What I would like to try is to look into it in a detailed level, because then we can start to build it from scratch and everyone can learn and understand what's going on. And I don't know the knowledge level of everyone about Kubernetes, about Terraform, about Ansible. So if there are any questions, just ask. Or if I'm too slow, also please tell me this. Like if you are like, we know this stuff, please move on. Then just let me know. I'm just guessing what I should show. So yeah, I will start.
I have a first question before we
Yes.
start. So why did you use Tanker and Helmfile?
Because I'm using Tanker to render all the namespaces, and when I create them, I'm also generating network policies for all of them. And that was quite a hassle in Helm.
Okay.
And I was always curious about JSONnet and Tanker, so I looked into it. And for a while, I considered to move everything from Helm to Tanker. But that's also quite the hassle, because with Helm, you have a lot of stuff that just works out of the box because a lot of other people support it. And with Tanker and JSONnet, there's less support in the community for it. So that's why I have it in a mixed setup now.
Okay.
I can show the Tanker stuff next week. I wouldn't go into this into too much detail because it's like a special case, how I use it. And I'm just using it for the namespaces and network policies, but we could definitely look into it. And yeah, that's the reason behind that. All right. I created a repository on gitlab.com /ekai/k3s demo. I can post it in the Zoom chat, then Michael can use it to put into the YouTube description.
I like your thinking.
And right now it's quite empty. There are a few links in here, a few key points what we are going to talk about. And yeah, over the course of this session, we will fill the repository with a little bit more stuff. I have to open my own notes. All right. So let's go to Hetzner first. So I'm talking about it like everyone just knows what Hetzner is, but I'm not sure if everyone knows what Hetzner is. So I'm going to show it for a second. Yeah, it's a cloud provider. We can log in here. Hopefully I'm already logged in, and I am. This is an overview of my projects. And here I have an empty project. Everyone can contribute. We will use this one today. And yeah, someone from Hetzner was so nice to send me some credits so we can create servers and networks and load balancers and volumes here for free for the day. Right, but the only thing I prepared was that I added an API token over here. So I don't have to expose the secret of it while I show you my screen. And I did the same with GitLab. I created an API token for GitLab. If you're on gitlab.com, you can go into your settings. Then I'm going to zoom in a little bit because I then know that you won't see any secret stuff. And there you can create an access token. And I did that. I created an access token, gave it API permissions, and then created it. It's down here, and it expires in 7 hours. So we can't do this session longer than 7 hours, because then the key is expired. And yeah, that's because we need this key on GitLab for Terraform, and we need the Hetzner API token for Terraform and for Ansible as well. Just so you know where those magic tokens come from that are now just in existence in my setup. So yeah, they are from here. All right. Let's go back to the repository. I'm going to try to show this in Visual Code because it's quite nice to have the editor and the terminal in one program while showing something. If anything is too small or something, then let me know. Yeah, what do we need for a Kubernetes cluster? Kubernetes cluster usually is built from some control plane and some worker nodes. And I think in the past it was like called the master nodes and the minions, but the naming changed a little bit more to server and agent. At least in K3s, it's always called your server and your agent. And the control plane is running on the server node, and your actual workload you want to run in your cluster is running on those worker nodes or on your agents. And so let's maybe start with a small cluster. We say we create one VM with the control plane and 2 VMs as worker nodes. And one way we could do this would be to go into the Hetzner web interface, go to servers, add a server, say it's going to Falkenstein. We select a size, then we give it a name, could call it server. So then we could click create and buy, and then we do it 2 more times for the worker nodes or for the agents. And if we want to have 30 worker nodes, then we do it 30 times. And that's terrible, because each time we do this, we could do a mistake. This takes a lot of time to do this. If we want to delete something and replace it, we would have to click here again. We don't want that. So it's industry best practice to not do this manually in the web interface. If you want to test something, that's fine, but in general, we want to put this into code to be able to reproduce it. And the standard software to do this in the cloud native world is usually Terraform. So if we go to, oh, that's the wrong link, sorry. Terraform. Yeah, Terraform, it's from HashiCorp. It's quite a nice company doing a lot of open source stuff. And we want to use Terraform to set up our base infrastructure on Hetzner. So what we need for this is to have Terraform support for the Hetzner Cloud, because Hetzner Cloud is working differently than other cloud providers. For example, AWS or Google or something else. Each one has their own API. And that's why we are going to look at the H-Cloud provider from Terraform. So the link is back here in the repository. Then we see that there is official support for Hetzner. This is maintained by Hetzner themselves, which is quite nice, because this way we always know that this will work with the Hetzner Cloud, because if they change their cloud, then they will also change the Terraform provider, because they want people to use it. So that's very good for us to have this kind of official support and not just a community project. I mean, community projects are nice and everything, but if you want to rely on this, it's cool if it's coming from the vendor itself. And yeah, then we can click here on use provider, and it gives us a little snippet what to do to use this provider. We are going to copy this part of it. All right, let's go back here. We create a folder in our project. Let's call it Terraform. I created a file, not a folder. And then let's create one first Terraform file where we put this in, because we are kind of managing our dependencies here. We could use Terraform to not only provide virtual machines on Hetzner, we could additionally create some virtual machines on AWS or create an S3 bucket on DigitalOcean. We could all put it in one place in our Terraform code. And then we would define more dependencies here. But for today, we will only use Hetzner Cloud, so that's fine. All right. Let's have a short look what else we could do. Yeah, we can, next thing, we're going to create a little main Terraform file, and in there we will actually put our definition of what we want to have. I will open. In total, it's quite a lot of code that is going to work together to make it work for us. So I prepared a few things in advance. So first thing we are going to put in here is some basic configuration. We have in here that we are telling us we have some variable that's just a arbitrary name I choose. And we are telling Terraform to use a special backend via HTTP. And then we are telling it that we want to use a provider called hcloud, which sounds very similar to this one, right? Our dependency is hcloud. So we want to configure this, and we give it a token. It's a parameter of this provider. And this one is coming from this variable. And yeah, where's this variable coming from? In our case, it's coming from an environment variable in my shell, which is hcloud, which is something like this. It's called Terraform var hcloud token. And then Terraform will automatically use it for this value. And where you store this variable depends a little bit on your preference. Yeah, sorry.
Is it case insensitive or?
I think it is, yeah.
Thanks.
And another way to define this would be to create a file in here and call this Terraform. I'm not sure out of the top of my head.
Terraform.tf files.
Like this, right?
Yeah.
And then you could also define it here, call it hcloud token, and define this, and then you could put git ignore in your repository to never push this file to your repository, because this token is secret. But often it's used like this if you are working locally, but I didn't want to put it in here for hopefully obvious reasons. So I'm not going to save that. Just so you know where this variable comes from. This token is already here in my shell environment. All right.
There's also an awesome git ignore. Might can put it later to the notes where it will show you which files shouldn't be ignored, and TF-vars, like you mentioned, should be ignored every time.
Let's just put it in there right now.
Yeah, Mossy could also explain a little bit to that. So literally the most you copied it. Okay. Yeah, mostly
you can explain, sorry.
Yeah. Mostly one of the steps is like ignoring the all TF-vars literally. And the other step is mostly also important because you can see that it has more TF files. So override TF-JSON, everything with underscore override. What this means is literally that you can, when you use, for example, an upstream module on Terraform or upstream Terraform files, you can override them locally to test your changes, but you won't commit them back into the repository. This is also really great. What I really like by the default, so that you don't have wasting your time on that. And I think the last part is mostly only that it doesn't store the CLI configuration.
Yeah.
And the current state files, what's also important. And
yeah.
the local Terraform folder.
And the next topic is a little bit about the state, because Terraform has a state, because it needs to know what is already what's already existing in your cloud provider, and if it's managed by Terraform or not. And that's by default, it will store a local file in this .terraform directory, and just store it there. And then if you go to another machine and want to use Terraform, you can't, because the state file is not there. There's a different state existing at your cloud provider than the state file tells Terraform that there is. And in the past, there were a few ways how to deal with this. And one of it was to use HashiCorp Cloud. They offer a cloud service where you store your state. You could use an S3 bucket in AWS, which I think was the most used solution. And then another way would be to put the state file in your Git repository. And that maybe works if you are working alone or with two people, but it definitely does not work with a team. And also you are putting your state, which could be sensitive, into a Git repository. So, and yeah, I think the last possible solution that existed until recently was to run your own Postgres database and use this as a state backend. I know this because we did it at my day job, and it's quite cumbersome to run a Postgres database to store your Terraform state, because what you actually want to do is using Terraform and not running a Postgres database. And I don't know, half a year back or something, GitLab released a nice feature. I think I put a link into it here. State backend in GitLab. So the GitLab API now allows me to use it as a state backend for Terraform. So I don't need to worry about all this stuff if I'm already using GitLab. That's really, really nice. For me, this was a point when I started to use Terraform for my personal projects because it now just works. And yeah, it's a little bit weird, the command you have to use. It's rather long. It's a Terraform init and then a lot of parameters. Let's check for a second if this project ID is correct. You see here an ID. And yeah, I think it's the same like above here. All right. So yeah, what is it doing? Basically, it tells Terraform to use those endpoints to store the state. And most of the state goes here. And then we have also some other options where it's logging the state that ensures that only one instance, one person is using the Terraform state at the same time, because you can't write into it from two different Terraform instances. Then we use my GitLab username and my GitLab token. Now, if you remember, I earlier told you that I created an API token on GitLab for me. So that's this one. So we're going to use this, and I'm really hoping that it works. We're going to the Terraform directory and pasting this long command. Now it's doing a few things. One of it is that it's downloading this Hetzner provider, which we defined in our versions file. And yeah, then it initializes the backend and it tells us that everything was successful. This is nice. And now if we run a Terraform command here on my machine, and one of you would initialize Terraform with the same backend, we would have the same state. And that's really, really nice. So let's do something. Terraform plan. Terraform plan gives me a preview of what Terraform would apply to my setup. And it says no changes. Why is it telling us no changes? Because there's nothing in here. We didn't tell them anything. So let's change that. First of all, we want to create an SSH key, because in the next step, we are going to create virtual machines and we want to be able to log into them. So we could, for example, look into the provider documentation over here, Hetzner Cloud provider resources, and then we can see there is hcloud SSH key. And for each resource that is available on Hetzner, there is an API, or there's an object here, a resource we can use. And then there's a little example of what we can put in there. And I prepared an SSH key for today. Let's put it in here. And then let's run Terraform plan again. And now we see that Terraform actually wants to change something. It wants to create this SSH key. Cool, let's do this. Terraform apply. Then it gives us a preview again, and we tell them yes. Let's look into the Hetzner web interface again. On the security, there's now an SSH key. That wasn't here earlier when I showed you that I created an API token. Not sure if you remember, but this page was empty. All right, one SSH key is nice, but it's not helping us much. Earlier I said, let's start with a small Kubernetes cluster, one server, 2 agents. Let's look into the documentation again. What looks like we want to use it? hcloud server, right? Okay, there's this resource type hcloud server, and we can define a few different things there. All right. Let's make it hcloud server. let's just call this one server. The last part is the name. And we want to have exactly one of it. It's not strictly necessary to define a count here if you just want to have one instance. I'm doing it anyway, so it's will be called server 0, our first instance. So in the future, if we want to add in another one, the naming is right. All right, and I'm going to copy a few things if you're all right with this, because then it doesn't take me forever to type here. So let's look into this. We are giving our server a name. And so this name is a name for this Terraform resource. And this name is what do we want to call our server in the Hetzner API? Like what name should it display when we look at our server? And we want to call it server dash the index of our account. So that's why our first server will be called server 0. If we would call it awesome, it would be called awesome 0. We want to use an Ubuntu image 24. We want to use the server type CX21, and we want to have a location in Falkenstein, Nuremberg 1, I guess. If you remember what we looked earlier at here when we said add server, the options are quite similar. Falkenstein, Ubuntu 24, and down here CX21, it's 2 CPUs and 4 GB of memory. So yeah, we can define all the settings like when we are using the web interface, but we put it in our code and we can reproduce it as many times as we want to. Here's also the SSH key. So let's go back into the code. I just said here is our SSH key. Let's add that as well, just like this. And here's one nice part of Terraform. There are a lot of nice parts about Terraform, but this is also one of it. We don't have to hard code this one here, like to put this one here. We can reference the ID of this object in Terraform. So when Terraform applies our configuration later on, it will make sure that it uses exactly this key that is already existing on the Hetzner side. And this way we can connect all of our different resources in Terraform to work together without the need of already knowing what their IDs are and stuff like that. We can just reference them and Terraform will take care of that. Now we are doing a little special part. We are going to create a little bit more. First of all, we are adding 2 labels. We can put everything there what we want to do. Just we can write any string or any pair of strings, it's key values. And we are going to use those later to decide which virtual machines are servers and which virtual machines are agents. And that's why we give it a quite unique name. We are using our domain, so it's really unique. Probably no other people would use this prefix. And tell it server true and agent false. So it wouldn't make much sense to say true for both. Technically, it's possible in Kubernetes, but let's just use this as a control plane server. All right, next thing we are going to do is to add a network. So this one does not exist yet. Let's maybe add it so it's a bit less confusing. Going to add it down here. So when you are doing networking stuff in Hetzner Cloud, you usually have a network, and then you also have a subnet, which has to be a part of the network. It can be the same or it has to be smaller. And their own documentation says there's no much use of this right now, but features will come. So we are just going to create one network, create a rather large IP range here. And then we are creating a subnet in there. Again, we are referencing, we reference the ID of this one, right? It's called K3S. And then the actual ID will be rendered later on. All right. And there we are using a subnet of this one. And here at the top of the server, we are now saying hcloud network K3S ID. So this way we are making sure that this server will be put into this network. And in a few minutes, when we have several servers, we will see how they're put together in one network to be able to reach each other with IPs from this network. All right. For the network, we need to add a little dependency here to tell Terraform that this object can only be created after this one is created. That's why this dependency is down here. So cool. We now have one server. Let's do the same for our agents. And I'm just going to copy it in here because it's basically the same. Sorry. So like this. At the top here, we have server, and here we have some agents. Now we put, set our count to 2 because we want 2 agent nodes. We give it a different name. The same is, the rest is the same except our labels. We tell it to server false, agent true, because they will be agent nodes. Let's save this. I'm checking my notes for a second. I think the next thing we can do is to apply this. Yes. I'm going to make my terminal a little bit bigger. Let's say Terraform plan at first. Nice. So it tells us that it will create a bunch of stuff. At first, the networks, the subnet, then an agent node, another agent, and in the end, the server. You can see here that there are a lot of values where it tells us known after apply. And for example, this ID, and that's what I mentioned earlier a few times, that the other objects will reference those IDs of other objects. So Terraform knows what needs to work together. Let's apply this and let's look into the 2 things at the same time. On the left, let's look at our dashboard from Hetzner. And here we do Terraform apply because it always amazes me how fast the Hetzner API reacts to this. Bam, there are already 2 servers. They are now booting. And yeah, if those animations stop, now they are running, we can log into them. And yeah, I think that's quite nice to just have like less than 10 seconds to just create servers. Cool. We now have 3 servers. That's all we need as a base setup to run Kubernetes. And if we look into networks, then we see that we have the subnet we just created with Terraform. And we have all 3 servers in here. And next time, not today, we will look into this a little bit more because we will add a bit more networking stuff to actually have a load balancer in this subnet and get traffic in there from the outside. But for now, we will just have those servers here. Yeah, that's good. All right. Let me think for a second. Yeah, one interesting thing we could look into is, for example, on gitlab.com, where our repository lives. I will make this a little bit bigger again. You remember we did this Terraform init command. And a few days ago, there was a GitLab release where they added a UI feature. Yeah, at operations, Terraform. We are now able to see this state we created. This is the state file that I mentioned that is by default on your local disk, and it's now living here in the GitLab API. And until a few days ago, it was invisible here. The only way to figure out that it exists was to talk to the GitLab API manually. Now this is quite nice. There are no fancy features here. You can't just like give me a preview of my state or something, but you can at least see that there is a state file. You can download it and then look into it. It's a JSON, so it's machine readable and human readable, but it's not so great human readable, mostly for machines. But you can also delete it or lock it or unlock it if it's locked. For example, if someone else or you are using Terraform and it locks this state, and then Terraform crashes and never unlocks it, then you have an easy way now to unlock it again. So it's one of my favorite features of the new release. Even though it's like small feature, it's not the gigantic feature. Like there are a lot of cool things in this release, but for me, this small thing is quite an improvement. Okay, so that's the Terraform part of our session today. Any questions in the call or in the live stream?
In the call, around the GitLab state file, I'm just having a quick look. Are there permissions to stop anybody with access from locking, unlocking, deleting that state file, or is that just open to anybody with permissions within GitLab?
Everyone who has maintainer permissions or more. But there's also no way to like temporarily disable it or something. It's either you're a maintainer or not. But for example, if you're a developer, you can't access it.
Yeah, it's just sort of getting an idea of what permissions are available there, and seeing that, it's always good to know.
Yesterday, I tried to use it with another repository where I had no maintainer permissions, and then it just failed when I tried to use the state backend with Terraform. All right. I'm not seeing the live stream chat, but I think I can open.
Yeah, mostly regarding to the topic to the access, I'm currently checking the docs. Besides that, it's also pointed out that you can use also the state as a non-maintainer, so as a developer, but you can only access it. So that means you can't change anything, but you can read what is the current state of our infrastructure.
Okay, yeah, that's good to know.
So you can also link this.
Right.
But this the feature with seeing it now, the state is really awesome in terms of that you can now see it in the UI and don't need to know in terms of, did you test probably, or can we test it now? What would happen when we create a new workspace?
In which way? What kind of workspace do you mean?
Terraform. In Terraform, you can create also workspaces. So
okay. Then you have to guide me through it a little bit. I don't know about that.
Let me check. Why is it called workspace? And let me check how the command was called. I can explain it also.
I'm going to commit the current stuff.
Okay.
So
workspace is the correct command.
Okay.
Yeah. Okay. But I can explain aside a little bit to the workspace. Okay. So literally, there are different steps you can do to have in terms of that we want to separate our environments from the infrastructure as code base. And literally more people, or in the past, I use this also for myself. I copied only the whole state file, but it's not needed. What you can do is you can create a new workspace. It will be managed in the same state file. And then you have a new clean Terraform environment where you can pull up anything you want to. So that means what you need to do, you can check it with Terraform workspace list. So
I guess that's backend dependent.
Okay.
But one thing comes to mind there when we look into the command we used to initialize it. What GitLab supports is to use something else here than default. I guess that would
then
be
we can have multiple, but it should be probably worth to create an issue for that you can't use workspace. Or it's a limitation of the HTTP backend. I'm not
that. If you want to use a similar mechanism like workspaces, then I guess it would be to use different state backends in here, like stage instead of default. And then you would have several state files in this list.
Yeah.
Would require a different workflow than you currently have, for example.
And mostly the idea behind the workspace is that you don't need to change your code for the environment. So that means you have a dev environment, a production environment, a staging environment, and you have only one state file with separated workspaces. And you can test them the features out that you want to. Or applying these configurations, it's bounded to the workspace, and you can name the workspace like you want.
Yeah. I'm just opening two links that Micah posted. But I think it's for a module registry, right? Not for workspace support. Okay.
No, it was meant for as an additional insight into what's planned or what can be what we want to add as GitLab for managing Terraform or making the integration better. One of them is a Terraform package registry, and the other one is the merge request widget integration, which outputs the Terraform plan currently, should also have more insights. And there are a couple of more things to come, and watch out in the linked epics. I think, yeah, protected state files so that developers can access that is also a thing. Let me see what that issue is. And I should probably just link it in the YouTube agenda as well. And another thing which is currently evaluated or will be soon evaluated is managing the Kubernetes cluster in GitLab with Terraform. But that's not directly related to our discussion.
Here's also a link I posted in the chat. Here's the official explanation of workspaces. So it was before Terraform 0.9, it was called environments. So it would be a better naming.
Okay.
So if someone wants to read it, you can read it also later. The topic.
I'm going to add this to the README as well. So what was called protected state and Terraform workspaces. So
yeah, I had a coffee chat with Victor Nagy a while ago, who's the product manager. And I think the protected state files and also the merge request integration are the ones which are anticipated next. But totally up to you with influencing the roadmap with more ideas, more comments, and so on, making the integration easier.
Yeah, I think that would be quite nice if GitLab uses Terraform for this.
I think the knowledge is there. I could, so my Terraform knowledge is not that deep, but change is hard in terms of not breaking things. But yeah, it's totally looking forward to that, because also for the 5-minute production app project, which we keep running, we're also using Terraform in the background, I would say, to provision AWS EC2 instances and hiding everything away. And actually, you're just deploying your app.
All right. So yeah, that's the Terraform part of the setup. And I think we have time until 7 o'clock roughly, right?
Yeah, we can also extend a little if you want
okay.
to.
Okay.
Just keep talking.
Okay. All right. Then the next part of it would be the Ansible setup to do some basic configuration on those nodes. And we will use Ansible for a few small things, and especially we will use it to actually install K3s there. And looking at the time, I guess the K3s part will come next week, but we can already start to set up our Ansible environment for it. So let's go back here. Yeah, Ansible is software for configuration management, and we can define our desired state in YAML files, and then apply this to our infrastructure. And then Ansible will connect to all our servers per SSH and apply the state that we want to have. And in this case, what we mostly do is install some packages, render some configuration templates, and put those rendered files there. And yeah, we will see what we will actually do with it. But before we can use it, we need to set it up a little bit. And so you can install Ansible with your own package manager. Like if you're using Ubuntu, you can use apt install Ansible, something like that. That never really worked great for me because then Ansible is installed as a global package, and usually I want to have a local version of the Ansible version and all the dependencies I need for this specific setup. So I'm using something called virtual environments in Python. Ansible is written in Python. So we are going to create one, and let's just call it everyone can contribute. It's a hard word to write, contribute.
We need a short handle with 3 or 5 characters.
Let's install this. And all right. So then we can now see we are using this virtual environment. And now if we do any Python things, then they will be installed in a local directory of my user instead of my full system. So if we look at where's Python living, it's now in home max virtual env, blah, blah, blah. All right. Let's create a new directory here in our project. Let's call it Ansible, because there's no relation between our Terraform code and our Ansible code. It's completely independent. There are a few ways how to combine those. So you can call Terraform as part of Ansible, or you can use Terraform to write some configuration for Ansible. That's possible, and that's are valid approaches. But in our case, we will separate those. So we can close all Terraform files for now and just look into the Ansible directory. And before I do something wrong, I'm going to check my notes. So in the Python world, when I have some Python requirements, you often create a requirements.txt file. It's completely arbitrary. You could name it however you want. And then we are going to put a few things in there. Especially, we want to install Ansible, and we also want to install Hcloud. It's a Python library to talk to the Hetzner API, and we want to install NetAddress. It's a library that Ansible needs to do some parsing of IP addresses. So that's why we put it in here. So if you are new to Python, pip is the Python package manager. And we are going to install something, and we want to read from, or we need to go into our Ansible directory to make it a little bit easier. Pip install, and then we want to read this from our requirements file. And now it's installing all our dependencies. This can take a few seconds because Ansible has quite a few dependencies because it supports so much different things. So it needs few more packages for this. While this is running, we can create another file here. Let's call it again requirements, but this time let's call it a YAML file, requirements. So this is not for Python, but it's for Ansible itself, because we are going to use 2 dependencies again. It's quite nice, right? We are often defining just some dependencies. We did this in Terraform. We added this Hcloud provider as a dependency. And now we are using a lot of packages from Ansible. And now we are using, call it plugins or modules for Ansible. And one of them, or they call it collections since a recent release. One of them is Hetzner Cloud. And one of them is DevOps. So if we go back to our README, here on GitLab, you can see that there is a hcloud collection and DevOps. Okay, yesterday the link worked. I think this one in the end is wrong. Yeah, this one. So that's very similar support-wise like the provider for Terraform. It's also managed by Hetzner themselves. So if they extend the feature set of the cloud, then they also are very fast at updating their Ansible provider or the Ansible collection. So you have full support for your infrastructure in there. And what do we want to do with this module? We want to use a dynamic inventory of it. I will explain this in a little minute. Right. Yeah.
Mostly because you are using now the Hetzner Cloud API endpoint to get the dynamic inventory. The reason for that is because Ansible needs an inventory to see which servers they want to provision. If you don't want tied to Hetzner Cloud, you can also use, there's a product, it's called Terraform Inventory, where you can generate it automatically. I linked it in the chat.
Ah, perfect. I just need to scroll down. Yeah, I think that's kind of the stuff I mentioned, right? That you can combine those two, that it writes the inventory for you.
Yeah.
Yeah, that's nice.
So then you can do it, I think, for every provider that you're using.
Yeah, let's put this in the README as well.
Or you can also test it out next week also.
Yeah, for example.
The difference between that.
So, right, so, and we will later on use this DevOps project. It's a project of Ansible libraries, Ansible modules, and we will just use this a little bit later to not have to write all things from scratch. We will just use one or two roles from them. All right. So back to our code. By now, Ansible is installed, which means we can now install those dependencies we defined here. And Ansible itself has another package manager, Ansible Galaxy, because the place where you can publish your Ansible modules, your roles and everything, or your collections, is the Ansible Galaxy. And then we're going to do this. Install. It looks very similar to the pip install command we did before, right? And this is probably just finishing because the Ansible Galaxy dependencies are not installed in the local directory, but somewhere in my home directory. I think they are in somewhere here, collections. And then we can see that there is this Hetzner library and everything in there. So that's why it's already here on my machine. Okay, cool. So I said dynamic inventory, and that's because Ansible needs an inventory. And the inventory tells Ansible what hosts exist, like host names or IP addresses, and maybe some special settings for those. And so let's create a directory, call it inventory. And then I think it has to be called hcloud.yaml. And there's only very little stuff we need to put in there. Just plug in hcloud for now. So next thing, we need to tell Ansible to actually use this. So we create an Ansible configuration file. When we run Ansible, then it will look for this file, Ansible config. And I'm just copy and pasting my configuration in there. So the important part is that we tell Ansible to look into this inventory file. We tell to use the root user. And for demo purposes, we also tell it to ignore if the host key is not matching. Because if you run this in production, you usually want to have this on yes, or you have some way you manage your SSH host keys. But for now, we will just ignore this security mechanism. Just if you copy this file for something else, please consider to not do this. All right. I think we should now be able to look at our inventory. In the beginning of the talk, I told you that we have this, that I have this hcloud token variable where my hcloud API token is stored, and the Ansible module is able to use the same variable, so I don't need to define this somewhere in the Ansible config right now. I can say Ansible inventory list. Hopefully it works. Yes, it does. So it's some nice JSON output. So if you want to parse this with some other program, that's easy to parse. Yeah, over here we have now all three of our hosts, and we can see that we have all this information available. We have those labels, we have the location, we have the type, we have the ID, we have everything here what we need, and that's nice. What we also have is some groups. One group is called hcloud with all three machines in there. And then one group all, it's kind of a default Ansible group where it puts this group. So all children of the hcloud group are also part of all. And if we had any other hosts, they would end in the ungrouped group, but there are no other hosts right now. So when we created our servers with Terraform, we added those labels. And now is the point where we are going to use this, and we are going back in our inventory configuration for this hcloud YAML, and we are going to do something nice. We are going to tell the dynamic inventory to create groups for us. So we create two groups, servers and agents, and we tell it to use this condition that put the server in here. If the label everyone can contribute server is on true, or put them in this group if agent is true. So if we save this and list our inventory again, then we can see that we have a new group agents and a new group servers, which only includes those machines. And this is quite nice because in the next step, we can use Ansible to apply specific settings only to one group. And overall, our machines will be configured similarly, but the server will have a little bit of different configuration than the actual agents, because the agents need to have some settings how to connect to the server. And yeah, Ansible allows us to put this into groups, and that's a nice way, yeah, to have this in a dynamic way, because now if we create new servers in Terraform and then run Ansible again, then it will already have those labels and just know if the new machines are servers or agents. So I like that very much of this way of using a dynamic inventory for Ansible. All right, next thing we want to do. Yeah, next thing we actually want to test if our Ansible is able to connect to our machines. And for this, we deployed an SSH key early on Terraform. If you remember, this one that exists in Hetzner is this key for me. And I want to tell Ansible to use this key to connect to my machines. So I'm going to create a directory here in Ansible. It's called groupvars. And Ansible has a way to define variables for hosts or for groups that are settings I want to apply to those machines. And I'm going to do this for the group all. Earlier we saw we have this group all right here in our inventory where all our servers are in here. And yeah, in general, you are completely free on what to put in there. But I'm going to put in a little bit of Ansible configuration to tell Ansible that it should use a private key file, which is stored in my home directory and has this name. So if you are having a different SSH key, you don't need this, or you need to adapt it. And I think I put it in the wrong directory. The groups RAS needs to go into the inventory directory, like this. Ansible inventory group RAS, and then the group is called all. Cool. Let's test our SSH connection. Ansible, then we use an Ansible module called ping, and we want to do it for all machines. That looks good. Everything is green, right? Yeah. We can now see that it gets a response pong from each of the machines. This means it is able to log in via SSH and then call some Python script. All right. The next step would be to do some basic configuration on the nodes, to install some packages. And then in my own setup, then I have a step where we configure the full firewall of those nodes. And I was thinking that at least for the first part of building this cluster, we would just ignore the firewall and then maybe add it later. If you build a production setup, don't add the security later, but maybe if you just want to showcase something, it's fine to do the security later to get faster to the point where we can actually see our Kubernetes cluster, right? I think Gary is leaving. So Gary, thanks for joining. Will we see you next week? Yeah, cool. Then see you next week.
Thanks.
All right, and then we would finally be at the point where we can actually install K3S, and then we can see this cluster. So, for example, I posted. So, if you are okay with this, then I would say we are done for today. So, I think now is a good point where we can cut it and continue next week. Except if you want me to continue, then I can do that as well.
No,
opinions.
I think it's really great. So first of all, thanks for preparing everything. I learned lots of things, and probably it's best to tease for next week and say, hey, we're pulling this together and actually deploying Kubernetes. So Kubernetes will be next week. And probably I don't have any questions. I'm a little mind blown, to be honest.
So what the goal for next week then is to be able to reproduce the screenshot I posted yesterday on Twitter. We want a Kubernetes cluster with 30 agents running and all in the state ready. And then we are at a point where we can deploy an application and it would just run on Hetzner Cloud, which would be quite nice. So that's a bit of a teaser what we are going to do next week. And yeah, in my experience, this moment feels quite awesome all the time. If you are at this point where stuff is running and you are seeing everything coming together, like Ansible, Terraform, K3S, and suddenly there are computers doing what you tell them to do. It's nice. So
automatically.
And then I'm not sure how many weeks we want to stretch this, right? But in this agenda, I added a few things as optional. Let's see. We can escalate this a little bit later on by doing everything in GitLab CI, which would be a little bit more connected to GitLab then again. We could try out the new autoscaler because since currently Hetzner is working on an autoscaler implementation for Kubernetes, which is nice. So it's stuff like we don't have to do it like spend the next 5 weeks doing Kubernetes stuff, but maybe you can work on it next week and then do something else the week after and then come back to this, whatever we want. And
is it cluster autoscaler?
Yeah, it's autoscaler for the nodes. Someone from the community, I think, Hetzner customer, he or she, I don't even know, is.
They could build a really cheap cluster then.
Yeah. They added a pull request to the upstream Kubernetes repository for the autoscaler, and then the customer asked Hetzner, hey, this pull request is almost ready, but to be honest, I don't want to maintain it. Do you want to do it? And I think Hetzner just said, oh, this is great. We want to do this. And so a few days ago, Lukas from Hetzner,
I found the issue probably.
Okay.
He
posted a screenshot of the working autoscaler. Yeah, here. After a few minutes, the nodes are ready. And this is not released, but the code is public, so we could try to work with this. I think Mike also commented, he commented, I would love to see that live. So
yeah, I have no objection to say, hey, we're doing this for the next 2 months, because I think it's a real great way to learn new things, like putting Lego bricks together. And I love Lego, so I'm totally up for let's try next week, and then we'll have another topic with the autoscaler, and then we have maybe a different idea of trying Hetzner Cloud, for example, and add some monitoring to it, and then integrate it in GitLab CI. And
I think I actually wanted to put this here, like deploy monitoring stack, because it's this way we can also talk a little bit about external DNS to configure our DNS dynamically, to get SSL certificates with cert manager, and to get traffic actually inside of our cluster with an ingress controller. I guess there are 2 additional sessions. So if we are out of topics, we can just continue to build this cluster forever. I assume mostly that Niklas has ideas for this as well.
We host our GitLab in there, our own GitLab with private certificates, self-signed certificates that you can use as a development machine. What I mentioned last week, I think.
Yeah. This we can do there as well.
And we can also use Cert Manager for issuing the certs.
GitLab CI runners as well, and then can use it as a development environment.
Yeah.
And then we're testing out the agent, the GitLab agent. What is really new, but it's an ultimate feature, I think.
And then
we need a license.
Probably I know a person who has a license, so I could use my license to do that.
I can also open up an access request for our group to become open source and get access. That shouldn't be a problem. I just need to know it in advance.
Or we testing with a 30 days free trial at first, so no one can test this.
Yeah, it shouldn't be a problem if you're working at the same company. No, but yeah, I'm totally up for everything. And I think when you're watching it for 1 hour every week, it's good enough. So with that, I would say thanks for watching, and thanks for preparing everything, Max, especially to you.
Yeah.
Thank you.
Bye-bye on YouTube, and see you next week.